Greetings and welcome to Flanigan's EcoLogic. I am your host, Ted Flanigan, and today we're talking boilers, smart boilers, more efficient boilers. We'll be speaking with Dan Nadav. He's the CEO of Enviro Power. Hey Dan, welcome to the podcast. How are you today?
Ted, thanks so much. Thanks for having us, and thanks for the opportunity to present Enviro Power and our SmartWatt boiler technology.
I'm looking forward to it, and I believe that you're in the sunny state of Connecticut right now as we speak.
As of today. Who knows about tomorrow, but today it is sunny and it's a lovely day.
That's fantastic. So we're talking boilers today, and where are, before, just a very simple question, where are boilers found in our society?
So boilers, if I refer to them as a combination of what really is called boiler and furnace, basically fuel-based heating systems, are you can find them in around 40 to 50 million buildings across the US. So pretty much half of all the building inventory in the US, stretching from east to west and north to south, have boilers or furnaces, or basically being fed by natural gas. That's basically the prime source of fuel, or sometimes propane, and who knows, in the future maybe hydrogen. And a similar situation exists in Europe. There are, obviously a larger, if you look at the European Union, a larger continent people-wise, and so we're talking about around 100 million of boilers and furnaces that are installed in the other continent, in Europe.
And then what do the rest of the people in the United States have if they don't have a boiler and they want heating for their home?
So this is electricity, obviously, and the way it evolved is very natural. So in very cold climate, or maybe not that cold, but when you have a decent winter, like here in the Northeast, Midwest, and the Rocky Mountain area, where you need many kilowatt hour on a given cold day, then natural gas probably does a better, more efficient work than electricity. But if you are in even California, or for that matter, Florida, and winter does not really exist there, and the only heat that you need is to heat your water, portable water for showers and dishwashers, then electricity can do a very decent job in basically providing the heat that you need.
But if you're in the cold winter in the Northeast, a hydronic heating system is a much more efficient way to go, and the boiler provides that heat for those loops, right?
Exactly. So we're talking about significant inventory of, again, around 40 to 50 million devices that are being fueled by natural gas, and using this great infrastructure that we have of close to 1 million miles of gas pipeline, transmission pipelines.
Now we're going to be talking about your SmartWatt boiler that your company Enviro Power manufactures and sells. What makes it so smart?
So what makes the SmartWatt boiler so unique and smart is the fact that it's probably the only solution that you can say on one end that it's a drop-in replacement to regular heating system, to regular boilers and furnaces. And with that, I mean, it really competes with regular boilers on price and the cost of maintenance and installation. And yet on the other hand, it is a boiler with a power plant inside. It's a boiler that is designed to generate electricity, very inexpensive electricity, basically while producing very efficient heat. And also, when the grid is not there, when the grid is unavailable for you, whether you need heat or not, to operate as a backup power generator. In other words, it's actually 3-in-1 solution. When you buy the SmartWatt boiler, you buy a very efficient boiler to produce heat. You also buy a generator to produce the electricity that you need daily, and a backup power just in case you need it. So 3-in-1 solution.
Well, now let's talk. This is pretty phenomenal. Let's talk about the sort of the thermodynamic efficiency, or the efficiency of a typical boiler. Would that be in the 50% range? I'm really stretching here. I have no idea. Is that about the efficiency of a normal boiler?
So there are two types of boilers, condensing and non-condensing. The majority of the boilers that exist here, and to a degree also in Europe, are non-condensing boilers that are by definition very inefficient, I would say. And those are mostly the boilers that we replace with our boilers, with the SmartWatt boiler. The SmartWatt boiler operates at very high efficiency, not very far from almost 100% efficiency, but it's not saying that a condensing boiler cannot reach that level of efficiency. But ask yourself, when you have condensing boiler, very efficient boiler at your building, in your home, what does it do? It produces heat, and that's it, no electricity. We do both with the same level of efficiency. Why it is important? Because ask yourself, from where comes the electricity that we replace? It comes from the grid. And what produces this electricity? It's still, to the most of it, thermal power plants that burn something. And most of the time, they burn it in a fairly low efficiency, which means that most of what they burn actually goes to the atmosphere, is not used.
And that's really getting to my point, that I think a typical power plant is what, 35 or 40% efficient. So you're taking natural gas, you're putting it in your boiler, and you're getting close to 100% efficiency, because you're, as I understand it, you're grabbing the vast majority of that latent energy in that therm of natural gas, and you're delivering that as heat through your hydronic system, and then you're taking the other portion that would normally be wasted, and you're using that in sort of a cogen application. You're generating electricity. Is that it?
Exactly. When you compare the output of the SmartWatt boiler to the output of the boiler we replace, basically with less amount of gas, which means reduction in the amount of fuel that home, that building is using, we can generate more heat and power. So the end result to the owner, to the end user, is basically a sharp reduction in the cost of electricity, because we generate electricity with less amount of fuel. So basically the cost to operate the boiler, the SmartWatt boiler, in comparison to the boiler we replace, is lower. So you save money on that. And we also reduce the amount of fuel that is used. I'll give an example. So take, for example, the Local Law 97 program in New York City, that occupies so many landlords. Pretty much almost every building is subject to that law, which is a quota on the amount of CO2 you can generate per square meter of square foot, of a building area. So basically, in order to reduce the carbon footprint, you can do two things. You can reduce the cost of, you can reduce the amount of electricity that you are using, and the amount of natural gas that you're using. When you replace all boilers in New York with the SmartWatt boiler, you actually capture both goals, because you then buy less electricity from, let's say, Cornell or National Grid, and then you obviously reduce the amount of fuel that you're using for heating. And what is the end result? And that's kind of the point before, why actually to generate electricity with the SmartWatt boiler on site rather than to buy it from the grid. The New York City, New York, has one of the cleanest grid in our nation, and yet every kilowatt hour of electricity bought from the New York grid is associated with 300 grams of CO2. A kilowatt hour of electricity that we generate is associated with 180 grams of CO2, so almost half. That's a sharp reduction, basically, just by replacing an old boiler with a SmartWatt boiler and generating your own electricity, not even counting the reduction on fuel consumption, which altogether brings, on average, a building in New York to CO2 reduction of around 10 to 15 tons of CO2 per year per SmartWatt boiler system.
You got me excited. It sounds like you said that your price point is the same as these furnaces that you're replacing, or these boilers that you're replacing, or approximately the same. It sounds like a win-win. It seems like business must be going very well. But let me ask you a question. I think you said in a call that we had a few weeks back that you're making a household boiler. And I think I read somewhere that it might save the average homeowner about $1,000 a year compared to a standard boiler. Is that right?
That's pretty much correct. You're right. Right now, what we have in the market, fully certified and in serial production, is what I call mid-market solution. It's a solution that is tailored specifically for multifamily apartment buildings. Whatever we design around the technology is very much targeting a specific niche. Our first niche that we have strategically decided to tackle, to go to is the multifamily apartment building niche. It's on one end a niche with a growing need to decarbonize. Think about all these 12,000, 15,000 buildings in New York, multifamily buildings in New York, other large cities. And yet on the other end, it's very underserved niche. There aren't that many options for those landlords interested in lowering cost of electricity or cost of energy and lowering carbon footprint. And that's basically the niche that we are focusing right now. However, the SmartWatt boiler solution that we have for that niche, which is called the SW300-6, is also a good solution for relatively larger homes, or I would say other commercial applications. Now, later on in the next 2 years, we plan to actually come to the market with a specific residential solution, a little bit smaller than we have right now in the market, that we really do the job on one end, providing the heat that those 1,500, 2,000, 2,500 square foot home need, and on the other end, provide them the baseload electricity and also capacity to go backup power with one device.
Fascinating. And then I take it you're probably also looking at the upper end of the scale, more industrial boilers. You got the mid-market is your multifamily, you got the residential, and then also a larger unit for industry.
The beauty of the SmartWatt boiler technology, sometimes compared to other technologies, that it has no size limitation. When we say that we really play in this $90 billion heating system replacement market, 10 million heating systems that are being replaced every year between here and Europe. We're really serious about that. We have right now one product, one solution for one niche, but nothing should actually stop us actually creating boilers that covers the entire arena, if you like, going to the smallest apartment building or smallest home and to the largest warehouses of Amazon, so to speak.
Oh, that's fascinating. Let's talk a little bit about the resilience feature of these boilers and the ability to island. As you said, if the grid goes down, let's say I'm in my multifamily apartment building, the grid goes down, my SmartWatt boiler is still producing hot water for my hydronic heating system, probably also producing water for the domestic hot water heating system, but then it's also generating power. Now, we're building a lot of microgrids out here in California, and so I understand a little bit about automatic transfer switches. But how do you wire a boiler into an electrical panel? Or do you have a sub panel serving critical loads, or how do you do that?
You'll see that I like this word, and I'm going to use it quite a lot during our session here. It's simple. We actually imitate. We better like to imitate when we can than rather coming with a whole new idea and reinventing the wheel. So we really imitate solar PV, the one that you probably have at your rooftop, and so many other Californians have and using, which is actually through an inverter. We're using the exact same inverters that exist and are part of the solution of PV. Rooftop PV solutions, and that's an easy one. First, they are very common in the market, easy to get, and most electricians know really how to connect that. So that's kind of how we connect to the grid or to your home the SmartWatt boiler.
But then what loads are you picking up? You're not generating enough power to power the entire facility. Typically.
So it really depends on the meter, right? So for multifamily apartment buildings, specifically those where each apartment is directly metered, and that leave you with really one meter that is easy to connect, which is the common area meter. That's, I would say, where we actually cover pretty much the entire load of that meter. So think about, a typical building in New York, Brooklyn, Bronx, 6 stories, 50 apartment buildings, and a common area meter, lights in the hallways, external lights, garage, etc. That's around 6 to 7 kW. And that's exactly, deliberately, obviously, why we actually designed the system with a turbine at that size. Because the idea on our end is actually to keep everything behind the meter where it's mostly valuable.
Yeah, that's great. And then just thinking about this, help me out. I'm trying to think. You mentioned the inverter. I get it. You have a generator inside your boiler somehow. Is it actually right inside of the boiler, or is it bolted onto the boiler? But somehow that generator, I want you to describe it. Somehow that generator is taking this heat or this steam or whatever it is, pressure, it's spinning and it's creating DC power. That's what's got to go into the inverter, and that goes AC, and then it goes into your electrical system. But physically, what is it? How is that generator in your system, built into your system?
Through my 20 years of career in the energy sector, I commercialized multiple technologies, and I found that one of the hurdles in commercialization is actually the complexities of those machines. At one point, I commercialized a super critical CO2 waste heat recovery system, just to say it can break your teeth. What's the beauty about the SmartWatt boiler is that it is very, very simple. So simple that I can describe to you and the audience pretty much with no drawings or the use of any professional terms how it works. So here is how it works. It starts with a boiler. A boiler is probably one of the least sexiest things that you cover in your program so far. It's a box, and I've obviously simplified it. So it's a box. On top, you have a fuel train where you mix fuel and air, and below you have a burner. And around the burner, you have a coil that takes the heat from the burner, bring it to water, and then travels to the home, either to your radiators or your showers or whatever you need it for. And so far, Ted, I describe any boiler ever invented. Where we come unique is that next to the burner, we incorporated basically a simple heat exchanger. It's just another heat exchanger. In this heat exchanger, right now you have water. When you turn on the boiler, the heat from the burner will evaporate the water into steam. And that heat exchanger is connected into a steam turbine. The steam flows into the steam turbine, spin it. The steam turbine is connected to a generator, and voila, we generate electricity. Just to make it a little bit more complex, then it's a closed loop. So we need to bring the steam back to water. It's called condensing the steam to water. So we incorporate another heat exchanger at the bottom of the boiler. And how we bring 220 degrees steam back to water to start the process again, we flow the return water from the heating system, now flowing at its coldest temperature, say 110 degree, into the heat exchanger. What happens when 110 degree water meets 220 degree steam? Obviously, it condenses back. And at this point, we pump it to the first heat exchanger that I described. So one heat exchanger is evaporator. The other section is expanding, generating electricity, and then condensing back to water. That's why saying it's a boiler with a power plant inside, it's absolutely a true description of what we have with the SmartWatt boiler. And in fact, we incorporated the most established power plant in the world, a closed loop steam turbine cycle.
That's fantastic. Well described. Now, you got a mechanical engineering degree, I think, from the University of Nevada. Is that right?
Not quite. I have many courses in engineering that I've taken in Nevada when I started my career in energy, just to make sure that I know what I'm talking about. Besides that, I have an M.B.A. Here in the upstate, from a university upstate New York.
And where did you grow up? Where are you from?
Originally and by accent, what you hear is Israeli accent that was softened after 25 years here. I hope softened.
No, I think you have wonderful. And I think you told me you worked in the wind industry for a number of years also.
Yeah, so my career for the last 20 years is highly focused on distributed generation, although quite few technologies. I started in geothermal. I spent a few years in the wind industry, both developing wind farms and selling large wind turbines. And then also spent quite a lot of time in waste heat recovery, which I see this as a blessing for two reasons. First, it's a fascinating field, and also it allowed me to work very, very tightly with the oil and gas industry, and specifically with midstream, because what we did back then is develop waste heat recovery projects on top of compressor stations in gas pipelines. And I think that it's important today, especially with all the changes that we're going through and all the debates and the arguments, should we go this direction or that direction? It's really to get a broad overview of really what we have here, and understanding the midstream industry and the oil and gas industry, as well as growing in the renewables, I think makes me fairly well-rounded in my capacity to generate views over energy topics.
Why do you think you got into distributed energy resources? You've been in all these different forms of distributed energy. What was the passion there, or what was the path that led you to that?
I'm coming from a family of engineers, and I think that it's in my blood to look into power plants and efficiencies, and obviously this huge trend that I've watching growing tremendously in the last 20 years of basically decarbonization of the entire energy industry is something that captured the imagination, I would say.
Yeah, yeah. And back to the SmartWatt boiler, is it fair to say that it's a cogeneration plant? It's just at a sort of a mini cogeneration plant?
Yeah, we call it a power plant, a boiler with a mini power plant. And yes, it is co-generating both heat and power. Absolutely.
Right. Let's talk about a few case studies. Wesleyan University, well known. I think that's one of your flagship installations. Am I right about that?
Yeah, correct. We installed a SmartWatt boiler as a pilot 2 years ago at Wesleyan University. It's one of their main dorm buildings. And last September, we replaced it with one of our first units that came from serial production. It's a great application and a very good experience. So far, the performance is close to perfect. We run non-stop, reaching thousands of hours of operation and many thousands of kilowatt hours. All in all, we save for the university for that building $1,000 per month. So do the math. This covers the premium that we charge on top of regular boiler in short few months.
That's fantastic. And just as a side question, where do you manufacture these boilers?
That's one of the other advantages of the SmartWatt boiler. So the main advantage of our approach, as I described it technically a few minutes ago, is with the fact that the power plant that we incorporated seamlessly is not very expensive, and therefore we really can compete with regular boilers on price, and since the installation and the maintenance is literally identical, also with the installation and maintenance, we are comparing apples to apples here. The other advantage is that when you take the drawings of the SmartWatt boiler to a boiler producer, they really understand what's inside, because pretty much 80% of what's inside are boiler parts that I bet you actually sitting on their inventory shelves already. So as a young company and coming to Enviro Power with, I would say, quite great of experience in hardware, energy hardware, I understand how difficult it is to go from prototyping, proof of concept, and even early sales into production. Production really requires deep knowledge and maybe even deeper pockets. So we wanted to avoid the risk and actually take advantage of the fact that we aligned so well with boiler producers. So from the get-go, the strategy was, let's partner with a boiler producer here. And we have formed a very strong relationship, very strong partnership with Burnham Holdings. It's a holding company of multiple brand names in the HVAC boiler market, owning multiple boiler companies, that covers pretty much all the boilers, from those that will go into a small house and those that will go to serve in industrial. And we produce with them. And basically they became our strategic partner and strategic investor here in North America.
That sounds great. A couple more questions. Maybe this is a tough one. The world is decarbonizing and electrifying, as you well know. I know that you said that your boilers produce less grams of CO2 emissions per kilowatt hour than the grid, even like a Con Ed grid, a clean grid. But are you at odds with those the trends about burning fossil fuels? Even if so much more efficiently. I mean, so much of what we're up to here in California is decarbonizing. I've tried to introduce fuel cells onto certain campuses, and same argument. I can say the fuel cell is cleaner than the grid, but how do you square with that question?
So first, I really hope that we are in odd in the future, because I believe that in the future we will have 100% clean grid, and at this point at least in the form that we operate right now, our society may not need this type of solutions. But we are talking about a fairly far away future, because let's not confuse ourselves with digital innovation and innovation in infrastructure. Digital innovations like the one that you have in your cell phone could be downloaded in a split of a second and maybe developed through, a few months of engineering efforts. Changing infrastructure is a completely different thing. At one point, I actually decided to check how long it took the car to replace the horse. You imagine that, it's a very straightforward replacement, and though it took us 4 decades to reach full saturation of cars and get rid of horses. So we are talking about changing infrastructure that was built over 100 years, and that's not an easy task, and definitely not something that takes that we can take for granted and assume that it will happen quickly. It will probably take some time. So we need to ask ourselves, what are we doing in the meantime? After all, we are talking about fighting climate change, and maybe I should bring it to the present and call it fighting climate changing. It's changing. It's something that is already happening. So per my example with New York, and that's an example in New York, if you go to Pennsylvania, it's double the amount that we save. If you go deep into South, it could be triple. All in all, in the US average, we are talking about 800 to 900 grams of CO2 per kilowatt hour generated, which is 4 times more than what we provide. So why not to take advantage of that and actually provide the capacity, the tools to the so many millions of landlords interested to lower their carbon footprint today. Now, in the future, when the grid is clean, there is a very good chance that also the pipelines will be different and flow hydrogen. Now, one of the advantages of the SmartWatt boiler is that the power loop is completely heat agnostic. The turbine or this heat exchanger that evaporates water to steam doesn't care really where the heat comes from, which means that if we move to a blend of hydrogen and even pure hydrogen, we don't need to change anything in the power loop, which is kind of the innovation element in the boiler. The only thing we need to do is to trace the industry and follow what other boiler producers are doing anyway, mostly in Europe, which is changing and moving from natural gas into hydrogen with the changes required into those boilers.
Oh, that's fantastic. Now, what do you do when you're not thinking about boilers, Dan?
It's a good question. And maybe the answer will be somewhat unusual. So in my deep background and far away past, I used to be a concert pianist. So moving into energy was coming from playing concert as a pianist, and I'm still enjoying playing and still enjoying listening to music and teaching my kids piano.
That's fantastic. Good stuff. Well, I've really enjoyed chatting with you, and I've learned a lot. And thank you so much. It's been fantastic.
Ted, thank you so much for the time and the opportunity.
We'll be in touch.
Absolutely. Thanks so much. See you.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.